Hi everyone, this is example 6 from chapter 12 in the student packet, and I'm making this video so that we can contrast this with example 7. So first notice that it says there's a box with 7 red marbles, 3 green marbles, and 6 black marbles. We draw one marble, put it back, and then draw another, which means that this is with replacement. Are drawing marbles with replacement independent events? We would say yes, and that's because drawing a marble does not affect the probability of drawing another marble. I could word that better because I know we're talking about colors of marbles, but that in effect is what this means. And it's because once we draw a marble, we're putting it back. Therefore, when we go to draw a second marble, we still have all the marbles in the drawer, and that first draw has no effect on the second draw. So we want to find the probability of drawing 2 black marbles in a row. So we're going to find the probability of drawing a black and then another black, and I'm using B for black. So because we're working with independent events, this is the probability of drawing a black times the probability of drawing a black. Well, what is the probability of drawing a black? We have 6 black marbles, but how many total marbles do we have? Well, it looks like we have 7 red, 3 green, and 6 black. That means a total of 16 marbles. And of those 16 marbles, 6 of them are black. So the probability of choosing a black marble is 6 out of 16. And we're doing that twice since we're replacing that marble back in. And when we put that in our calculator, we get 0.14. Notice that I'm not trying to reduce these fractions. I'm not doing fraction multiplication. In the end, I'm just writing as a decimal. Please don't take the time to mess with the fractions. Just put these in your calculator and find that decimal answer. So for part C, it says find the probability of drawing 1 green marble and then 1 red marble. So now we're finding the probability that we draw a green and then a red marble. Again, because these events are independent, I can multiply the probability, of drawing a green marble times the probability of drawing a red marble. Well, we have a total of 16 marbles still. The probability of drawing a green is 3, so this is 3 out of 16. And the probability of drawing a red is 7, so that's 7 out of 16. And again, if we just go straight to putting this in our calculator, we'll get 0.082. And finally, for part D, it says find the probability of drawing 1 red marble and then 1 marble that is not red. So before we do this calculation, let's figure out the probability that a marble, actually no, let's just do it straight away since we're working with fractions anyway. So we're finding the probability that we choose a red and then we choose some color that's not red. So this is going to be the probability that we choose a red marble times the probability that we choose a marble that's not red. Well, how many red marbles do we have? 7. So 7 out of the 16 are red. So how many of these marbles are not red? Well, I have 3 green and 6 black, which means that 9 of these marbles are not red. So 9 out of 16. Could have also used the complement. If I do 16 minus 7, I'll get 9. And again, when we put this in our calculator, we get 0.246.